So continuing on, we have problem 13. A baseball player throws a ball through the air. The figure below shows the path that the ball follows. The ball is moving from left to right. And we're given these 5 points. So basically what we are asked to do is to comment about each of those points, the intervals between them for the 3 things listed: horizontal velocity, vertical velocity, and acceleration. So really what this is getting at is letting me know if you understand what's happening with projectile motion. How does the components of velocity change over the trajectory? How is the acceleration changing? The relationship between all of those. So for horizontal velocity, we know that for a projectile, the only force acting is the force of gravity. That is only in the y direction. So nothing is happening in the x direction as soon as that projectile, that object, is in the air. So that means the acceleration in the x direction is 0. So ax is equal to 0. If the acceleration is 0, that means the velocity is constant. Whatever the velocity, horizontal velocity, is at the start, it will be that same amount throughout. So that horizontal velocity is the same. It's constant. V sub x is the same for each of these points. And this is something that you dealt with straight in the note packet. For vertical velocity, what's going on with that? Well, we know that we have an acceleration in the y direction. As soon as the object is in the air, no matter if we're going up or if we're going down, the acceleration is the same. The acceleration due to gravity is always constant. It is always 9.8 meters per second, and it is always pointing downwards. Doesn't matter if the ball or the object is on the upward part of its trajectory or the downward part. The acceleration due to gravity is always 9.8 meters per second and always pointing downwards. So with that, we know that on the way up, the velocity is positive in the y direction, because that's what's causing the ball or the object to move up. So we have a large v sub y to start, and then we have a little bit smaller, and then at our peak, we have v sub y equals 0. And then it switches direction. Remember, the velocity should follow the path that the object is taking. So since we're now moving downwards, we have a velocity in the y direction, or the negative y direction. And that's increasing because that velocity is in the same direction of acceleration now. And so that is basically what's outlined in 2. And then for 3, the acceleration. We've already touched on this, but just to reiterate, the acceleration in the x direction is 0 by definition of projectile motion. Projectile motion says that the only acceleration or the only force acting on the object is gravity, which means that we only have acceleration in the y direction, the acceleration due to gravity. So that means the acceleration in the x direction is 0. So for a problem like this, this is the level of detail we're looking for. You really need to highlight what is the same for all these intervals, what's different, and to really address each of those issues. Moving on, got problem 14. An amusement park ride whisks you vertically upward. You travel at a constant speed of 15 meters per second during the entire ascent. You drop your phone 4 seconds after you and your phone begin your ascent from ground level. How high above the ground is your phone when you drop it? Find the maximum height above the ground reached by when you drop it. So what's going on is you're on this ride, right? you're moving upward at a constant speed. The phone is in your hand. Maybe you're flailing your arms a little bit or just like holding it outside of the ride. And then it slips. It drops out of your hand. You're moving upward still. So the phone is starting with some velocity, whatever you were moving at, that 15 meters per second. And now, as soon as you drop it, it's in free fall. That phone is in free fall. It's in the air. So it's like any other problem that we've dealt with for objects in the air, where it starts with some velocity. In this case, it's going to be what it was moving up at with you, 15 meters per second. And then it is in the air at that point. So it's going to keep rising, but it's in the opposite direction of acceleration. So it's going to slow down, and then it's going to reverse its course and fall to the ground. So to find how high above the ground is the phone when you drop it, well, that's just this stage right here. This is part one, where you and the phone are moving up at a constant velocity, and then you're just finding out what the distance is, given an initial velocity, a time, and you know the acceleration in the y direction. Since we're moving at a constant velocity upwards, we know that the acceleration is 0. So really, it's just a initial position plus your velocity times time. So that's part A, where you find that you get 60 meters right here. And now, as soon as you drop it, that is when you're in free fall. So at the first part, you may be tempted to put G in for acceleration. But that's not the case because we are not in free fall. So not in free fall. Because we have something that's lifting us up. But for the second stage, as soon as you drop it, that is when we're in free fall because it is in the air. It's away from anything. And the only thing acting on it is gravity. So to find the maximum height, what is the key about maximum height? Maximum height is code word for the point where the final y velocity, or the point where the y velocity is 0. The maximum height is a turnaround point. It's moving up, it reaches a maximum height, and then it starts going back down. So that crossover point tells you that the velocity is 0 in the y direction. So you know the initial velocity because that is what you were traveling at. So your phone was traveling at that same speed as well. You now know the initial height that you were at for that. And then you can solve for the final height because you know you're in free fall and you know the acceleration. So doing that, you find that from the ground, the distance is 71.5 meters for the maximum height. One thing to kind of watch out for is there may be a way, depending on what you choose for your initial height, you may have chosen 0 for your initial height as soon as you drop it. Just be aware that you would get 11.5 meters. Just know where that distance is being measured from. It's okay if you called that your 0 point. So if you called this drop spot your 0 point, it's okay to choose that. But just be aware that your final result is going to be measured from that point. It's not going to be measured from the ground. So you want to add the position where you drop the phone to this final height to ultimately get 71.5 meters. So that's the only thing that I could see that you could solve it that way, and there's nothing wrong with that. I'm definitely seeing it done, but just be aware where you're measuring from. Moving on, we have a stuntman problem, stunt person problem. You have been hired as a consultant on a movie set to determine the safety of a stunt based on your knowledge of physics. The stunt calls for a secret agent to run horizontally off a level roof of 10 meters above the street below into a window in the building across the street. The window is 7.5 meters above the street, and the street is 5 meters wide. How fast do they have to run off the roof in order to get through the window? The insurance company for the movie requires the speed of the actress be less than 8 meters per second going through the window for safety reasons. Determine whether the movie meets the safety standards. Use your problem-solving framework to guide your analysis. So this is a typical problem that you could be asked. It's a projectile motion problem. The projectile in this case is the actress running off the roof. And what you are asked to find is how fast do they have to run off to get to that point? And then the other is, what is the final velocity going through the window? Because you need to address whether or not, you have to address the question whether or not the movie meets the safety standards. So don't just put a number as an answer, you need to answer this question. And so this is where the problem-solving skills will transfer to your everyday lives, is you're typically going to be solving problems that require like a word answer. You may use some sort of calculations or approximations to back up your claim, but ultimately you're going to be addressing a claim in words. So this is a way to practice this. So got the problem set up here. You're traveling, the person is traveling at a horizontal. It's running along a flat roof. So the velocity is going to be entirely in the x direction. So we know that if the initial velocity is entirely in the x direction, we know the initial velocity in the y direction. The initial velocity in the y direction is going to be 0. So to start off, the first thing you want to do is you want to figure out what is the time that it takes the person to reach the other building, that window, from that launch point on the building on the left. So you know your initial height. So we know our initial position at 0. The actress travels down to a window that's located below. That's why the position's negative. And that is the window is located 2.5 meters below the left side building. You may have noticed that I labeled my 0 point at ground level. That's actually not matching up with the numbers I have here. The y equals 0 point needs to be up at the level of the building. So be careful with that. Even I make mistakes. You need to be consistent with the numbers you're using. So ultimately you can solve for time, because as soon as the actress leaves the building, they're in free fall. Once you have the time, and if you know the range, then you can solve for what the initial velocity was in the x direction. Because the acceleration in the x direction is 0, that's all the information you need. So substituting in those values, we find that the initial velocity in the x direction is 7 meters per second. Since there's no y component, that is the initial velocity. Now to get the final velocity, we know what the final velocity in the x direction is. That velocity is constant, so it is what the initial velocity was. Now we just need to solve for what the final velocity was in the y direction. We make use of Pythagorean theorem to combine, and we find what the final velocity was, 9.9 meters per second. That is not your final answer. You need to answer what the question asked and whether the movie meets the safety standards. Since the safety standards are 8 meters per second, this does not meet the safety standards because the velocity